The idea of payback period is usually the easiest one for people to understand, so let's talk about that first. The idea of a payback period is how long will it take for us to recapture the cash that we laid out. In other words, if we have a machine which cost $1 million and saves us $250,000 per year, it would pay for itself in about 4 years. 1 million is 1,000 thousandths divided by 250,000 would give us a result of 4. The math is easy, and the supervisor in any factory can do this math and understand the idea of payback period. Payback period is important in a lot of conversations that we have because it is something that everybody can grapple with and understand. If I were to draw a timeline for it, it would look like the timeline shown. I'm going to have an initial cost, which I would have to consider, and then a series of cash flows that are going to come after that. So if we're looking at that timeline, with the cost of 380 and the subsequent cash flows of 100, you know that your payback period is going to land in between the third and fourth period. If I were going to label these things, the cost of $380,000, I might use several labels on that. I might call that my initial investment. So my initial investment is, in this case, $380,000. I might abbreviate initial investment for I sub 0. I0 is simply the investment at time 0. And in your financial calculator, you might use that as CF0, the cash flow at time 0. The payback period is a valid criterion to use in a decision-making process for several reasons. Number one, it does give a good idea of what's going on with a series of cash flows and how long it's going to take us to recoup them. But it also gives an idea of how long is a company exposed, how long is a company out that certain amount of money, and how long then are they exposed to the risk of loss of their initial capital. It may also give an idea of sort of the velocity of money, in a sense. How long is it going to take them before they can put that money back into some similar project? How long is it going to take them to recirculate their money and generate a new benefit? There are, however, some weaknesses in judging projects based solely on the payback period. For one thing, it doesn't take into account the loss of value that a dollar has over a period of time. If we're waiting almost 4 years to recapture our $380,000 on a project, we're going to lose some of that spending power during that time. So we might need something a little bit more sophisticated to give us an idea of what's going on. Number two, there's no real way to compare the payback period to another project and get an idea of which one is truly the more valuable project. It's only going to tell us how long is this money going to be out of pocket for us. As an alternative to the payback period, or perhaps as an additional criteria to use along with the payback period, I might use the internal rate of return. The internal rate of return, or IRR, is the interest implied by a stream of cash flows. It's the rate of return that we're going to get from a stream of cash flows. Sometimes a company is going to have a required rate of return which it has to exceed in order to approve a project. In financial theory, this is going to be the WACC which the company faces, the weighted average cost of capital, or the WACC which would be appropriate for a specific type of project. In more common terms, we might call that the hurdle rate. It is the rate which a project has to exceed in order to get approved. It's the rate over which it has to leap in order to get approved. So if the internal rate of return is greater than the hurdle rate, the project should be approved. And if the internal rate of return is less than the hurdle rate, the project should be rejected. The internal rate of return is a valid criterion. It's talking about the rate of return which is given to us by a stream of cash flows. Therefore, it takes into account the time value of money, and it gives us an idea of whether this is or is not a beneficial project. But there are some weaknesses. It doesn't give us an idea of scale, and it doesn't really provide us with something that is what I would call a perfectly objective measurement. And so we've got another measurement called net present value that we'll talk about in a moment. In terms of using IRR with different audiences, again, I find that the rate of return is something which is fundamentally easy for people to understand. So I can, again, have a conversation with somebody in the corner office, or I can go down on the shop floor and I can talk about a project, and I can talk about the return that we're going to get from a project in percent terms, and somebody can look at a project and say, hey, this is getting a 17% return, that's pretty good, or this is only getting a 3% return, that's rotten. Most people will understand the concept of a rate of return. They might not understand all of the computations that go into the internal rate of return, but you don't have to muddy the conversation with a lot of jargon. We can simply talk about the rate of return a project is getting. Between that and the payback period, people are able to get a much clearer picture than they had before. To use the calculator to figure out the internal rate of return, we're going to use the IRR function. Now this is very similar to what we've done before, and we're going to be getting into, again, the finance functions. So if I'm on the TI-84, I'm going to go into my finance functions, and I'm going to scroll down to what is the 8th alternative. Alternative number 8 is IRR. If I press enter, it's going to pull that up on the screen. It will say IRR with an open parenthesis. If I use the BA2 plus or the HP12C, I'm going to be using their built-in functions for internal rate of return. On that same cheat sheet we used before, we've got a scenario for this, and the scenario is this. You can buy an investment which has a set of cash flows as shown below for $1,100. What is the internal rate of return for this investment? Now we're using the same cash flows we did before, only this time we're given the price and we're not given the interest rate. All that the calculator is going to do is solve for the interest rate. So we go through the same process of entering our information in. We're going to use, on the BA2 Plus, the enter button and the down arrows. Remember to set your cash flow 0 now, cash flow at time 0, to a value of $1,100, and it has to be marked as a cash outflow. So you need to change the sign so that it's showing you a negative number there. We're going to enter the $100, $200, $300, $400, and $500 cash flows as we did before. We compute for the IRR, and the screen should show you 9.0020. For the HP12C, similar process. We put in 1100 and we press the change sign button, so that's going to give us a negative number. We're going to use that to indicate a cash outflow. We'll enter in the cash inflows as shown, and we solve for the internal rate of return by using the F function and the FV function. And that's going to give us 9.0020 on the screen. 9.002% is the answer there. For the TI-83 or 84, we're going to use the syntax similar to what we used for the NPV function. IRR, and we have our open parenthesis, that's the prompt the calculator gives us. We're going to put in our initial cash flow, which is an outflow, so it's a negative 1100, then a comma, then again we open the curly brackets, we put in our string of cash flows separated by commas, close the curly brackets, close the parenthesis, and press solve, and it should give us the same answer, 9.0020. As before, if we have a circumstance with a repeated set of cash flows, we can solve for that in similar fashion. We need to put in our cash outflow, our cash flow at time 0, and we're going to make sure that we tell the calculator to repeat the appropriate cash flow the appropriate number of times. So we have our $100 cash flow used once, our $90 cash flow used once, our $80 cash flow used once, and our $25 cash flow used 6 times. Now, it's important to make a note of how to figure out how many cash flows are used. In the case of these examples, it's being told to you that you're going to use it for the following 6 years. But in some of the homework and exam problems, it might simply be said that for years 4 through 9, you'd be using a $25 cash flow. If that's the case, then you have to make sure that you're counting correctly. Remember, 9 minus 4 is only 5, but we have 6 instances of that cash flow being repeated. When I'm teaching this in class, I count on my fingers so the class can see me do that. And what I don't tell them is, I do that in private too. Shh, don't tell anyone. It's okay to count on your fingers. It might be a little embarrassing if somebody catches you at it, but if it gets you the right answer on a business problem, it's worth it. Another criteria we're going to use to determine whether a project is worthwhile is the net present value, or the NPV. What this is the present value of a stream of cash flows minus whatever we spend to get those cash flows. So it's going to be the present value net of the cost. The decision criteria is this. If NPV is greater than 0, the project should be approved, and if it's less than 0, the project should be rejected. If the NPV of a project is equal to 0, what that tells us is this. The discount rate that's being used on those cash flows is going to be equal to the internal rate of return that those cash flows would give us. If the internal rate of return is equal to the discount rate, we're going to come up with an NPV of 0. And the internal rate of return is that rate of return at which the NPV of a project would be 0. Net present value is a valid criterion because it's going to tell us a specific dollar figure which is being generated towards the company's value as a result of this business decision. In other words, if we have a project with a $300,000 net present value, that tells us that this project should generate $300,000 of value above and beyond the normal rate of return which we would expect from the company. The discount rate being used for most projects, as I've said, is going to be something like the weighted average cost of capital. And so this is going to generate us return above and beyond that weighted average cost of capital. If the NPV is greater than 0, that tells us that the internal rate of return is going to be greater than the hurdle rate, or the WACC of the project. If the NPV is less than 0, it tells us the internal rate of return is going to be less than the WACC for that project. There are some weaknesses of judging the project based on the net present value. For one thing, it doesn't really give us an idea of scale in terms of the amount of return that we're getting from the dollar figures that we're laying out. If we're looking at a $300,000 NPV project for which we have to spend $30,000, and a $300,000 NPV project for which we need to spend $3 million, there's a significant difference in terms of the amount of return that we're seeing from it, from the company's standpoint. And it has to do with how many dollars we have available for our budget in terms of what projects we would approve. But it is another piece of the puzzle. It's another piece of this decision-making process that we go through in creating value in a business. To use the NPV function in your calculator for finding the net present value of an actual project, we're going to use the same function we did for the uneven cash flows, but there's a difference. The difference is that initial cash flow, that CF at time 0, is going to be something other than 0. Now previously we had simply put a 0 in and I said we'd come back and do it differently. This is that time when we're doing it differently. So think about the uneven cash flows. What if you could buy those cash flows for $1,100? What would you do? You'd put in a negative $1,100 into that slot. Remember, the $1,100 is going to be a cash outflow, so we're going to tag that with a minus sign for our calculator because we're following the sign convention. The sign convention says that the minus sign is going to be indicating a cash outflow. Your financial calculator requires a cash outflow somewhere in the time value money computation, so without it, it's going to show you an error. It's going to be the same thing if we're using a stream of cash flows or the repeated cash flow that we went through before, and with the same sort of an adjustment. Instead of a 0 initial cash flow, we'll enter in the appropriate cash outflow in the right spot in our calculator. So in this case, if we have an initial investment of $250,000, we'd enter in a negative $250 where we put in that initial cash flow before. I'd like to talk about one of the other criteria that I mentioned, and that's the profitability index. The reason I'd like to talk about that is that I believe it is required for at least one of the homework problems. What the profitability index does is it puts the projects into the same scale and provides a single easy-to-read number from management. So what the PI is going to do is it's going to take the sum of the present values of those cash flows and divide it by the cost. The decision rule is this: if the PI is greater than 1, we have a positive NPV. If the PI is less than 1, we'd have a negative NPV. So again, it should give you the same sort of a decision that the net present value and the internal rate of return are going to give you. What I find personally is that the profitability index loses a certain amount of valuable detail. It does give us sort of the one-stop shopping approach for decision making, but I don't like my decisions to be quite that loosey-goosey. I don't know a lot of managers who use the PI as a primary decision-making tool. The three that get used are the net present value, the internal rate of return, and the payback period, usually in that order. Now, when you're computing the profitability index, it's important to not get confused between how to compute that and how to compute the net present value. The profitability index is simply the sum of the present values divided by the cost. The net present value is the sum of the present values subtracting the cost. In sloppily written notes, it's easy to make a mistake and see that, so just make sure you got those clear in your mind if you're in a hurry on an exam or working on a homework problem.